So this video comes as the third in a 4-part series on ICA. You can find the full tutorial on my website with links below the video. Once you've run your ICA, you can move on to inspecting your components. Go to Tools, Inspect Label Components by Map, and then this will ask you how many components you want to display. Your components are ordered by variance if you've followed the previous tutorial, which means the biggest components are first and they gradually get smaller as you move along the list. You can choose to display all of them, or you can choose to select perhaps the first 34 or so. But importantly, the number of components you have will only be equal to the number of channels you have in your dataset. This is just a byproduct of the process of ICA. So what are you looking for in an eye movement component? Typically, identification will make use of 3 things. Firstly, the topographical map. Secondly, the time trial graph. And thirdly, the activity power spectrum graph. First, the topographical map. For blinks, you're looking for activity clustered entirely at the front of the head. You don't want to see activity stretching further back across the scalp. For sideways eye movements, you want to see opposite polarity activity on either side of the front of the head. For both types of activity, you'll want to check the continuous time trial graph. What this shows us is how the activity is distributed within the dataset. So you want to ensure that this looks fairly random and scattered across different trials and different time. What you don't want to see is one singular bad trial, or the activity occurring consistently at the same time in every trial. Finally, both blinks and eye movement should have maximal power below 10 Hz. What you're looking for is this nice slope down from 0 to 10 Hz. If a blink meets these criteria, you probably want to click Accept, which counterintuitively turns to Reject. It's important for me to note that I'm giving you an example here of really nice ICA components, but it's possible that when you look at your dataset, you might find that you've only got a left sideways eye movement or you haven't got any at all. ICA typically works a lot better for blinks than it does sideways eye movements because blinks are a lot more consistent. Sideways eye movements can be of a different length, people can be looking in different directions, and it often struggles to model these as well as it does blinks. So if you're not entirely sure, what can you do? Well, as you go through and select components and turn them red for reject, you can see what this does to your data. When you press OK, this doesn't actually remove these components from your dataset. You're given a second option just to have a look and see what the selection of these components has done by clicking on Tools, Remove Components from Data. Here you can press Yes, then Plot Single Trials. Now what you can see is your data with and without these components. What you should be able to see is an identical overlap between the blue and the red lines when there's no eye movement activity. But when there is, for example, this blink here, you should see that the red signal remains fairly unaffected by it, whilst the blue signal shows you your original data where the blink should still be intact. What you're trying to make sure here is that by removing the components, the only areas of data that you're affecting are those where you have eye movement activity. If your 2 lines are distinct throughout your data set, when there isn't eye movement activity, then it's clearly influencing your data in a way that you weren't anticipating. If that were the case, you would need to press Cancel, go back to Tools, and go back to Inspect Label Components by Map. You can now deselect components until you're happy with the effect that the ICA is having on your data. If your ICA looks really not right, your blinks seem to violate the 3 criteria I've given you in this video, or perhaps your ICA component removal is affecting your data in ways that you don't want it to, you'll want to have a look at the next video, improving your ICA decomposition. However, if you're happy with what you've done, you can press Accept, and then you can save the dataset.